Hi, my name is Don Bagwell from the IBM Advanced Technical Skills Organization, and this is the fifth in a series of video demonstrations on WebSphere Application Server for zOS. In this demo, we're going to explore the optimized local adapters, otherwise known as WOLA. WOLA is a cross-memory exchange mechanism that allows a Java application in WebSphere to communicate with a program in an external address space using very low-level address space to address space, memory-to-memory copying for its communications. The benefits of this are it's very efficient. It has a very low latency, it's extremely secure, it's bidirectional, which means that the program outside of WAS can call into WAS or vice versa. The program in WAS can call out to the program. And it supports transactionality. The external address spaces supported by WOLA are CICS, IMS, batch programs, Unix System Services programs, and Airline Control System, otherwise known as ALCS. Before we show WOLA in action, let's take a quick review of our environment, and we'll start on the WebSphere side. And in WebSphere, we have a cell-level environment variable set that enables the overall WOLA function. We have a JCA resource adapter installed that comes with WOLA. It's called ola.rar, and it acts like any other JCA resource adapter. The application in WAS is going to connect to the connection factory that's defined under ola.rar. And then down in the security profiles, there's a single cbind profile that is created that is what controls access to the WebSphere zOS server using WOLA. In the WebSphere admin console, if we look under Environment, WebSphere Variables with a scope of cell, we see our environment variable of WAS daemon only enable adapter set to true. If we look under Resources, Resource Adapters, we see the WebSphere optimized local adapter installed into the runtime, and if we click on that link and go in and take a look at the J2C connection factories defined, we see OLA defined with a JNDI name of EIS/OLA. And finally, if we look under Applications, WebSphere Enterprise Applications, we see a deployed application. If we click on that application and go and take a look at resource references, we see that this application has a resource reference of EIS/OLA, and it is mapped to the JNDI of the connection factory for the WOLA resource adapter. And here's the security profile that we mentioned earlier. The cb.bind.z9 * profile was actually created when the runtime was created. Here we're granting access to that profile for the CICS region ID. That's what allows the CICS region to register into the server using WOLA. Now let's look at the CICS side of this equation, because there are some components that need to be installed into the CICS region, and the JCL to do that is supplied in the WOLA samples that comes with the product. And if we just quickly walk through these, we see that one of the first things that gets installed is the task-related user exit, which provides the low-level connectivity over WOLA into the WAS server. A link server task is provided that shields the CICS programs from having any knowledge of WOLA whatever. A control transaction called BBOC is provided. We'll see that in use in just a second. And the sample program that we're going to use is called OLA CB01. It is a simple COBOL program that echoes back messages that come to it. And if you look in the source of that, you'll see it has no knowledge of WOLA whatever. And finally, we tie this all together with a concatenation of the WOLA modules to the DFH RPL for the CICS region. If we log on to the CICS region and issue the command CEMT inquire program and mask on BBOA*, we see all of the programs for WOLA installed into this region. If we inquire on the transactions for BBO*, we see the link server task as well as the BBOC control transaction. In this environment, we have the PLT updated so the task-related user exit is started when the region is started, but the link server task is not started automatically, so we're going to do that here. We're going to use the BBOC control transaction to do it. We're going to use the keyword start server, and we are going to name the registration name that is going to be used when we register into the server, and the server is going to be specified by indicating the cell short name, the node short name, and the server short name. And the rest of these parameters are spelled out in the info center, which we'll take a look at in just a second. Let's issue this command and see what it tells us. And there it is. The registration into the WAS server is complete and successful. There's a zOS modify command supplied with WOLA that allows you to display the registrations into a server, and here we're showing you an example of that. Modify the server short name, display adapter daemon registrations, and there's the kicks xreg registration that we initiated when we did the BBOC start server a moment ago. The WAS zOS Info Center has many very good articles on WOLA, and one in particular we'll draw your attention to is the one that can be found by searching on BBOC, and that'll give you an article with all the information about how to use the BBOC control transaction that we just showed you. Another Info Center article we'd like you to be aware of is one that can be found by searching on OLA APIs, as shown here. This is the Optimized Local Adapter for zOS APIs article. And in particular, what it provides is the return code and reason code for the various APIs. And the BBOC start server command that we issued a few moments ago issued a BBOA1 reg to register into the WebSphere server. And in the event that that threw a return code reason code back at you, you could come to this article to get information on what the problem was. Now we're ready to show WOLA in action. Here is the web application deployed in WAS zOS that will use WOLA to talk to the OLA CB01 sample program in Kix. There we see the data that we're going to send over. We specified the register name, and that is the registration that was created when we issued the BBOC start server that created a registration into WAS. That name is the pipe over which this communication will flow. And the OLA service name is the name of the COBOL target program in Kix. So we're going to run this and see what the response is. And we see that it answered back. It got the message and it echoed it back. So that was only one invocation. Let's have some fun. Let's issue 100. And there we see that 100 invocations takes just that quick. But what fun is 100? Let's do 1,000 invocations. And we're done. We can go scroll all the way down to the bottom. And we see that 1,000 we're done. Let's go to 5,000 and see what happens with that. And we're done. So what that shows you is that it is quite possible to do multiple iterative invocations of a program in Kix over WOLA in a very rapid fashion. For this part of the demo, we're going to reverse the flow. We're going to have a program in Kix invoke a Java program in WAS over WOLA. So here's the environment, more or less how we left it before. And for this demo, we're going to use a sample program called OLA util, which is a 3270 program, and that'll be the program in Kix we'll use to initiate the call over into WAS. We're not going to need the link server task. The link server task is for outbound WAS into Kix, but not Kix into WAS. It can be there, it can be up and started, that's fine. It's just that this invocation is not going to use it. The true is going to be there and be used because it's always required for WOLA communications using Kix. And over in the WAS side, we're going to not use the ola.rar JCA resource adapter. Once again, it can be installed. It's just not going to be used for this communication flow. And the application that we're going to drive is going to be one of the samples supplied with WOLA called OLA Sample 2. It has an EJB that serves as a target for WOLA invocation. So what we're going to show is using OLA util to create a registration into the named WAS server and then drive a number of calls across that WOLA connection against the OLA Sample 2 program. Here's the 3270 screen for the OLA util sample application, and for the send message data we put in whatever data that we want. For the question register first, we're going to say yes, and the reason why is we took down the registration we used in the first demo, so we're going to have OLA util reestablish a different registration, and we're going to have it use a register name of kicks test. The service name is the target EJB in WAS, and that is the JNDI name of the deployed EJB, the OLA Sample 2 application. The next three items name the server, so that's the server short name, the server node name, and the server cell name. And the number of tests to run, we've set this at 5,000 iterations like we ran before. And let's see how this works. PF4 will invoke the service over in WAS. So here goes. Setting up the registration, and done. So in this case it took 4 seconds to establish the registration into WAS and run the test 5,000 times. This demo is going to be very much like the previous demo where we had kicks talking inbound to WAS, except here we're going to take kicks completely out of the picture and we're going to introduce a batch program that's written in COBOL that is going to use WOLA to invoke the EJB in WAS. The batch program uses 3 of the APIs. It's a relatively simple batch program. The BBO A1 Reg API is going to establish the registration into the WAS server. BBO A1 Invoke is going to invoke the target EJB some number of times. We have a perform until loop built around BBO A1 Invoke. And when the number is up, we've reached the end of the counter, then we tear down the registration and the batch program stops. So let's take a look at the kicks program. If we scroll down to the procedure division, we see where we're setting up the variables that name the register name and the cell, node, and server short name. We put a number into the loop limit. We set the text message that'll be sent into the WAS program, and we also name the service name, and remember that's the JNDI name of the deployed EJB. Program is using the BBO A1 Reg and bringing in the parameters that were set above. And then here is the perform until loop, so it loops until the loop limit, which we set as 5,000 up above. Here is the BBO A1 Invoke API being used with the various parameters set and the values for those being pulled in from how they were set above. And then when the loop limit is reached, then it calls BBO A1 unreg, tears down the registration, and the batch job completes. And if we run this job and look at the output, in this case we saw that it took 3.45 seconds of elapsed time. Now remember, that included setting up the registration as well as running through the 5,000 loops. It took a little less than a half of a second of CPU time. Here are the messages that were being written out. It registered into the server, and then we start looping around. And if we max to the bottom, we see that it completes its 5,000 messages in and out, and then it unregisters from the server. And that's the end of this video demonstration in which we took a look at the optimized local adapters. We looked at 3 scenarios: outbound WAS into kicks using WOLA. We also looked at inbound from kicks into WAS using the OLA util samples. And finally, we finished up with inbound COBOL batch into WAS zOS using the WOLA APIs. There's more WAS zOS demonstrations in the other videos.